This next activity is called Listen Up, Speaker in a Jiffy. And what we're going to get to do today is build our own speaker. And it's a pretty fantastic activity because what you get to do is find out and discover the relationship between electricity, magnetism, and the production of sound waves. Now let's think about this. What we've got here is a radio jack that attaches to a radio, and it sends electrical impulses through this coil of wire. There's a magnet right inside of here. Now let's think. Why do you think we have a coil of wire around instead of just one wire? I'll give you a hint. Whenever an electrical current travels through a wire, it also produces a magnetic field. So why do we want to have a coil of wire rather than just one wire?
Make it stronger.
To make what stronger? The magnetic field, exactly correct. And so inside here we've got a magnet that reacts to that magnetic field that's being produced. And so as the pulsating magnetic field is generated by this coil, the magnet inside also pulsates up and down in response to that, and then it moves the bottom of the cup back and forth. The bottom of the cup in this case is acting like a, does anybody know that word? Yeah.
Diaphragm?
Like a diaphragm, exactly correct. Good. And so that diaphragm moves back and forth, which also moves the air molecules back and forth inside the cup. And that produces a sound wave, exactly correct. Okay, we're going to go ahead and get started. You've got step-by-step instructions in your activity packet, and we've got those here for you today. Who wants to read step number 1? Yes, right there. Vicki.
Turn the cup upside down. Loosely take the magnet so that it sticks up from the center of the cup's bottom.
Okay, everybody grab a cup. Find the magnets in the cup. And be working in pairs. Okay, each building one speaker. And this is what you should do, is tape it like this. Okay? Now, I want to turn your attention to helpful hint number 1. It says, don't cover the magnets with too much tape. Anybody have any ideas why that is?
Insulate it.
Yeah, it could insulate it. Could interfere with the magnetic field. That's correct. Good. Make sure that you're using, though, enough tape to actually tape it to the very bottom of the cup. Not the sides. Let's go right for the bottom. You bet. Because we've got to get that bottom of that cup moving back and forth. And no matter what you do, if you get the connections right, you'll get a speaker. So don't worry too much. And we'll find out who made the best speaker because the best speakers will be the loudest speakers. Very good. Didn't want to give it away. All right. I think we're ready for step number 2. Who wants to read that? Yes, right there. Sylvia.
Take the ice cream sticks on the outside of the cup as shown.
Yvonne.
Cut a 5-centimeter strip from the index card. Roll and tape the strip into a tube with about a 2-centimeter diameter. The tube will have a thickness of about 3 card layers. Make sure the tube fits easily around the magnet and can move freely up and down over it. Okay, here we go. All right. There was another helpful hint, actually, that I didn't put up there, and that was if you can make the 3x5 card not overlap too much, that's great, meaning something like this. We've got one tube about this big around, okay, that only has one layer. All right, so it's not several layers on top of each other like that. One tube, about like that, taped together. Kind of tricky, but 2 people working together, one holding, one taping, should work well. Okay, good. Good. Now you might want to check that around your magnet to make sure that it moves freely up and down. Who wants to read step number 4?
Cut a tiny slit in one end of the tube. Run the wire through the slit and wrap it around the tube about 50 times. Make sure the wire doesn't overlap. When you have a nice, neat coil, put 2 or 3 pieces of tape over it to hold it in place.
Okay. So why don't everybody just pick up your tube? Why doesn't everybody pick up the tube and cut a couple of slits right there and there, just in 2 places on either end. Just a 1/4 inch slit or so, 1 centimeter.
How much wire do you want on the inside of the tube?
On the inside, none. It will all be coiled on the outside. Okay?
You're just anchoring it there then.
We're just anchoring it. That's right. Okay? Now this does lead me to helpful hint number 2, which I will read now. It doesn't matter if the coil overlaps too much. So don't worry if when you're winding your coil, if the coil overlaps. It does not seem to matter in the actual working of the speaker. What you might want to do is measure out a length of about 15 feet, cut the wire, and then coil it up. And that's another way that you can encourage kids to experiment back in the classroom by increasing the number of coils, increasing the number or the size of magnets that you use. Those are great experiments. But only change one variable at a time or else you don't have a controlled experiment. Don't forget that. Okay. One way that I've coiled is coil and then slide it down, wrap it around, slide it down, wrap it around, slide it down. You know, it's really important to actually do these activities ourselves because then we understand what these activities are like to do when the kids try them. And some of them do take a little bit more dexterity than one would imagine, so we need to be patient with ourselves and the kids. We've actually gone through helpful hints 3 and 4. Make sure the coil surrounds the magnet in close proximity, and make sure that you leave both ends of the wire exposed, at least 3 inches. I just said 2, but 2 or 3 inches. Either one will work. 3 inches is easier to work with. Okay, we're coming on quickly to helpful hint number 5. Do we all have our coils ready to go? Okay, helpful hint number 5. Sand. This is really, really important. Sand the enamel off the exposed ends of the wire. You'll see it get shiny when you actually succeed in getting that enamel off of that. Slide your tube coil down over the magnet and tape it firmly to the ice cream stick. Okay, so slide it right down over, coil end down. Try to get it so that the coil isn't actually touching the very bottom of the cup. Make sure that the magnet remains independent within the tube, as it will need to vibrate inside of it. Now, I just said something interesting. For the first time, I said the word vibration. We need to know that vibration is at the heart of all sound waves, okay? It's something going back and forth which creates a physical movement of molecules, all right? That's at the heart of all sound waves, is vibration. Who wants to read number 6? Darnell, excellent.
When it's your team's turn, twist the end of your speaker wire around the end of the copper wire connected to the headphone jack on the radio. Then tune in your favorite station. Hold the open end of the paper cup to your ear and listen to the results.
Okay, this is the jack that we're using. You can also use a standard earplug jack that plugs into these little transistor radios. Let me hold up one of these radios as well for the camera to see. Okay. This jack, you just have to make sure that you buy jacks, and again, you can get these at Radio Shack or any electronic supply company. Plug right into there. Just make sure that you've got the right size. If you don't, of course, it's a problem. All right, now, what you're doing here is connecting both of these wires. This is a mono, not a stereo cord. Not a stereo. It's a mono cord, okay? You connect both of these wires to the exposed wires on either end of your coil. Now, if they touch, what's going to happen? It'll short out and it won't work. Exactly correct. So make sure that they're not touching when you connect them up. Yes. Oh, no. One wire to one of the wires from one end of the coils attaching to the separate individual wires. Let's go ahead. What I would do is turn on your radios without plugging in the jack and first find an FM, I'll repeat, FM station that's coming in pretty well. Put up your antennas. Make sure your radio's on FM. Okay. When you've got a station, plug in the jack, then turn the station up all the way. These speakers work very well, but they're not really loud, so you need to turn up the music as loud as possible to get as strong a sound wave as you can. Sounds good. Okay. Okay, go ahead and plug that in right there. Yep. Is it working? All right, we have our first successful speaker. Let's hear it for us. Very good. Very good. Excellent. Right out of the gate, too. Let me hear it. Okay, the last helpful hint is hold the stick, not the cup, while listening to the speaker. Why would we want to do that? Any ideas? If we hold the cup, what might we be doing? Yes, it can stop the vibration. Exactly. You guys are thinking. That's great. So this is the way to actually, and this is working very well. Good job. I can hear it clear as a bell. Excellent. How are we doing over here? Do we got it? Is it working? This is even better than theirs. Just a little bit. Either that or it's just a better music station. Okay. All right. Good. How are we doing here? Did we get it?
Yeah.
Wow. This one's even louder than yours. We're getting better and better. That's good. How are we doing, Darnell? Is it working? Yeah. I can't believe it. Okay. I can't believe it. All right, it's just that we got 4 for 4 right off the bat. That's because you followed step-by-step instructions. Yes, sir?
What's the highest power source you can go with?
Well, usually you shouldn't use any kind of radio that plugs into the wall. You should always use the battery radio. That's a good question. One of the things that you can use for the radio jack is a standard earplug that you can find at an electronics supply store. Now, what you do with this is make sure that it fits, of course, into the radio, because if it doesn't, that's a real problem. I think we already showed you that. But actually test it out to make sure, okay, because that can cause major hang-ups when you go to do the activity in the classroom. Now, you might be wondering, well, what do you do with the discarded ear section that you cut off? Well, it's a wonderful piece that you can use with your kids as a wrap-up. Look at this. If I were to take this apart, what do you think I might find in there, teachers?
Magnet.
A magnet. Why? What together would they make up?
Electromagnet.
Okay, electromagnet, and it would create a speaker. Exactly. It's a little speaker. So it has the three major pieces of a speaker. Look at this. What's this metal piece, do you think? The diaphragm. Let me just get this out here. All right, there we go. It's also magnetized. And what do we have inside, underneath that diaphragm? A coil and a magnet, exactly. So, Tim, this is a wonderful wrap-up to use with kids in the classroom.